You're a flood expert who claims to see abundant evidence of Noah's flood all over the Earth. Can you give us a sort of a destination list of the places we're going to today?
Certainly. Niagara Falls, Wave Rock in Western Australia. We then travel to North Africa and look at the Eye of the Sahara, and then also go to the Fairy Chimneys in Turkey. And finally, I thought we'd go underwater as well. There's some fascinating landforms there in the Sunda Shelf in Southeast Asia. I think the biggest challenge I face when we look at all of these 5 features is essentially time, in that the argument that it took millions of years can be dismissed in almost every case. I'm suggesting that things have moved a lot faster in time. How do I then explain that? 4,500 years ago, a global flood occurred, smashed the Earth to pieces. And then what we have seen since is minimal change. Since that catastrophic flood, catastrophic ice age, we are left with a historic landscape, not a currently being formed landscape.
So, Ron, you're a flood expert, and we recently had you on to discuss 5 famous landmarks that confirm Noah's flood. So, this went so well that we've really wanted to have you back again so that we can discuss another 5 landmarks that also confirm Noah's flood. So, before we start, can you give us a sort of a destination list of the places we're going to today?
Certainly. I thought the Niagara Falls, very in northern North America, very one that people recognise. Yep. Also, Wave Rock in Western Australia, beautiful feature. I thought we'd then travel to North Africa and look at the Eye of the Sahara.
Ooh,
that's an incredible feature as well, very large one. And then also go to the Fairy Chimneys in Turkey.
That's so whimsical. That's cool.
It is. But finally, I thought we'd go underwater as well. There's some fascinating landforms there in the Sunda Straits, the Sunda Shelf in Southeast Asia.
And so just quickly before we start, do you want to refresh for those who have not watched this before, what are your credentials?
Well, I have a PhD in geomorphology or fluvial geomorphology. They're big words, but essentially it means I study landforms and the processes that create them. So, for example, I would ask questions like, why is that hill there? Why is that gorge there? Why is it this shape, these dimensions? What caused their creation? Was it flood flows? Was it wind? Was it surf? What was it that created them? So I was looking at landforms worldwide, and essentially it's landforms. That's why I thought it would be very interesting to look at 5 different landforms.
Yeah. Well, that's really cool. To be able to see some of those landforms that have convinced you that maybe there's an alternative perspective to this normal evolutionary perspective. So out of these 5 landforms, what would you like to kick us off with?
I thought something dramatic that most people are aware of, and that's Niagara Falls.
Okay, let's go.
And so Niagara Falls is not just beautiful as tourists find it. It's actually majestic. It's incredibly powerful, let's put it that way. And if you've been to Niagara Falls, you'll know you're going to Niagara Falls long before you get there.
Oh, really?
There's a real sound, a vibration that's occurring, tremendous sound as you step closer and closer to it. And then there's this awesome beauty of the mist and so on rising up from the waters as they fall into this gorge over the waterfall. So a really spectacular sight. I thought it'd be a good place to start from that people are aware of.
That's amazing. It sounds almost magical. And I'm sure there's a lot of people who have been there. So can you explain to us, what is the geology? And can you use plain language so we can all get it? Because I'm not particularly qualified in geology.
Happy to. Well, first of all, Niagara Falls occurs on the Niagara River, linking 2 of the lakes in North America. So it's on the border of Canada and the USA for those who have not been there. And essentially, it's a very simple structure geologically. There are 3 basic layers of rock. The top one is essentially a dolomite, and it's a resistant rock. So it stops the erosion rate from being rapid. Underneath that, you're going to find some shales right at the bottom.
Mm-hmm. And those would be slippery, right?
The shales right at the bottom are extremely easily torn apart.
Okay.
So they're torn apart. And then in the middle, you're actually going to find more of a limestone, a little bit more resistant. So you've got resistant, partially resistant, incredibly weak.
Okay.
And so that gives you the reason why you have a waterfall is that the underneath is eroding, causing the top to collapse in. Yes.
And so you're telling me that the top part has been collapsing, and does that mean it starts slowly retreating over time?
There is a rate that is measured. It's slowed down a little bit lately because of works that they've been doing on water supply and so on. But the classic rate is about 1 to 1.5 metres per year of erosion that's been going on. And since it's not that far from its beginning, it's considered to be quite a young waterfall. So in a scientific sense, secular scientific sense, it's considered to be somewhere in the order of 7,000 to 9,000 years old.
Thanks for watching the interview so far. Just a quick one. If you haven't already, make sure you click that subscribe button so you can see more of this content. Back to the interview.
So you've mentioned the secular scientific side of it. If I went to the Niagara Falls and I was listening to a secular scientific tour, what would be the explanation, the general explanation that would be given?
The argument given is essentially one of it follows the last ice age. So North America, of course, large parts of it, Canada and parts of the USA were covered by ice during that ice age. It wasn't global, by the way, as many people think. It was only in certain parts of the world, particularly in the northern hemisphere. So the ice age covered the area quite deeply with ice. And as it melted then, it began to retreat off that area, which is now known as the Niagara River area, creating flows of water as the water drained from the melting ice.
Okay.
And so therefore they say since the ice began to melt about, say, 11,000, 12,000 years ago, the actual river started to form at about 7,000 to 9,000, and the actual gorge then would have started to form at about that time. So they say it's a post-ice age feature.
Okay. You are saying the retreat hasn't been happening too long. Do you agree with this secular take on it, or would you have a different viewpoint?
I have a slightly different viewpoint because when they do the calculation of distance and erosion rate, what they're assuming is uniformitarianism.
Okay.
And what that means is they're implying that the rate of erosion has been constant over time and that the processes of erosion are the same today as they were in the past.
Okay.
So you're getting a constant rate and a constant process.
So that's a history question.
Yes,
And
yeah.
it's an assumption that you have to make in order to try and measure as clearly as you can.
That's right, and that's
because
why
the minute you take away.
And that's why they've got that figure of 7,000 to 9,000 years is actually the gorge as being actually created at that time. I'm going to argue that that's not the case because whenever we see the retreat of ice, we see the flow of water can be massive, and the underlying sediments or deposits are also quite easily fractured, torn apart. There's no vegetation holding it together and all sorts of things. So I would argue from a scientific point of view that the rate of erosion as the ice began to melt was massive. So we cannot assume that the rate of erosion was the same or that the processes were the same because it would have been ice runoff, not river runoff or lake-to-lake runoff.
And so we're thinking the sort of runoff that cuts glaciers through mountains. The glaciers would cut through a mountain and not just a gradual water run.
Yes. So what I'm saying is the water flow following at the retreat of the ice would have been massive.
Okay.
Because that's a deep layer of ice. And so it would have been a massive, so it would have torn apart that underlying shale quite early and rapidly.
Yep.
What we see today is the current rate of erosion from the current processes. We can't go back in time and say those current processes and the current rates apply back then. That's not logical. That's not logical thinking.
What you're telling me is that this actually fits much better with a creation model, which has a much shorter time span, a global flood followed by a short and intense ice age, creating the perfect conditions for the Niagara Falls to form.
Correct. And I guess a final point there is I'm not challenging the geology of that region. I am not challenging the basic processes. What I'm challenging is the rate of processes, and slightly different there in the ice runoff compared to river runoff. But overall, what I'm really challenging is time. And I'm going to repeat that a few times during our little chat. Time is the issue to me.
All right.
Not necessarily the geology or the morphology, the shape, or even the processes at times, but time is always going to challenge me.
Okay, sounds good. So where are we going next?
I thought we'd come to Australia.
All right, let's
and
go.
have a look at a small feature called wave rock. and that's in Western Australia.
And this is number 2, right? So tell me what we're looking at here.
Wave rock is a fascinating feature. It's almost like you wonder whether time is moving or not, because it's an incredible piece of granite that's shaped like an unbroken wave.
Like frozen in time.
Like frozen in time, just sitting there like that, ready to break. So you wonder when you look at it, is this real?
Is it going to fall?
It's a complete granite layer there. You know, it's easily 10 metres deep or height, 110 metres long, or translate that to feet, 30 feet or 300 feet plus long. And so it stands out on a landscape that is otherwise quite barren and quite flat.
What are we going to hear if we're going to go to the Wave Rock? What are we hearing?
Well, what you'll hear is if you're going there as a tourist, is a classic description. It is granite. Mm-hmm. It's a lovely piece of granite. It goes quite deep, in fact, into the earth.
Okay.
And they'll argue on site that what's happened is over time, the weathering, the so-called decay of the rock, that the water was coming in deeper and rotting the lower granites, but keeping the top ones intact. And so as erosion then caught up to it, all that lower section was just simply basically flushed out, washed away. And so you've got this shape there that was created before exposure. Okay. So before it was exposed to the natural forces, it was actually a decay or decomposition of the rock in depth at an earlier period, a much longer period of time, now is exposed through simply erosion. And so you'll get that sort of an argument put to you.
And then do you agree with this? And if you don't, then can you explain to me why not?
Well, again, as I said earlier, I agree with the geology. Mm-hmm. I agree with the morphology and all those sort of things. I don't think they're taking a more broader perspective of the site. Because whilst you see this lovely unbroken wave, what you need to look at is next to that wave, going away from the wave, is a 1 kilometre wide valley floor, or almost like a river channel, as though it was a mega river channel. And so you're seeing this rock there almost like the bank of a river.
Okay.
Because when you look at a floodplain river, you'll see often they're curved just like that on one side. And then you've got a river channel. So my immediate interpretation is that it is the bank of a river channel, because when you look at it from a satellite, you can actually see a larger river that is no longer used today. It was handling a runoff that was massive at some time in the past.
Okay.
And that was the process that carved, with the flow of water, massive flow of water, was carving the actual shape on a meander bend.
Okay.
Like that.
That's amazing. All right. And so when we're looking at Wave Rock, you're saying that there was some huge runoff that's happening, and it wasn't, it was exposed to the elements already. It wasn't done underground.
That's my argument, because I can't, from all my experience, I can't understand how you'd have a process of decomposition of a rock at a deeper level than the surface rocks when the rock is homogeneous. It's really a very classic piece of granite. Doesn't have differences in it, no access to the lower sections, all sorts of things. I just find that exceptionally hard to explain over that particular site. To me, it's far simpler, as you see with most rocks. When exposed to the surface processes, they will show erosion classic to the surface, to the current processes and so on.
Yeah, and you mentioned there was a little comment to me earlier when we were just having a quick look at some of this before. Something about the concept of granite forming quickly, which surprised me.
Yes. That's another disagreement, I guess. I'm not disagreeing it's granite, but again, it comes back to time.
Okay.
And I think, yes, there's been a lot of work done highlighting that granite can be formed much more rapidly, not millions of years, but can be done quite rapidly in a very short period of time. And so if anybody wants to follow that up, that you'll find on our creation.com website articles on the rapid formation of granite, then it can occur very rapidly indeed. Okay. And so, yes, so I agree with that point. Thank you for pointing that out.
Yeah, because I just remember it surprised me when you came across it. I was like, oh, really?
Yes. So in other words, a piece of granite was being formed rapidly, being eroded at the same time by massive flow of waters, not from an ice age, but from the tailing end of the flood, the recession stage of the flood. And those sort of channels that we see there at Wave Rock, we see all across the world.
So it's not just wave rock?
It's not just wave rock. We see similar channels that are in front of wave rock worldwide.
Okay.
In fact, in some countries we've identified them, up to 50% of all the major valleys look as though they don't belong there.
So you're telling me that there was a big erosion that was happening and the river just came through afterwards?
Yes.
It was not the river to start with. It was just a drainage.
It was the drainage from a massive amount of water on the continents.
And so where are we going next for our third trip?
I thought we'd go to North Africa because there's an incredible feature there called the Eye of the Sahara.
That's a cool
And
name.
it's a cool name, and it's in the Western Sahara area. And so it's an incredible, incredible feature that you probably wouldn't even notice at ground level, but would see it from a satellite or up in the air.
So if I was there in the Sahara, all I would see was a bunch of random dunes and some pointy-uppy bits.
Some pointy-uppy bits, yes, you can use that terminology.
not very scientific,
some weathered ridges, and so on. But they're in a massive circular concentric in this form, 40 to 50. Now, on satellite, you see it exceptionally well. But on the ground, you'd struggle to identify that. But as a landform feature, it is such a beautiful feature if you're up in the air looking down.
And so when you're looking at this, what is it? Is it a meteor crater? Is it a collapsed volcano? What are people saying this is?
Good question. That was actually thrown up in the early days before we actually got onto the site and could really have a good look at these sort of features. No, there is no evidence whatsoever that it's a meteor site. Certainly there are no remnants of meteor or that. No evidence of a volcano either. There are no lava, no tough material, all sorts of things like this. All of that is missing completely. So it's neither a meteor nor a volcano.
But what would be this? If I was looking at this from a secular tour, would that be what they tell me, or what am I going to hear?
No, what you'd be told these days is that it's a massive dome that was once there. So you imagine a huge dome, and what you had then, that dome was made up of quite a variety of rock types, actually. And so you've got all sorts of rocks. Some of them are easily weathered, some of them are hard weathered. They're all laying in lovely layers, but it's a massive dome. Now, the top of that has been taken off.
Okay.
And so what you're then seeing is these incredible concentric.
So if I sanded it down, kind of.
Basically, yes. Very good. Sand it down, you're going to see all the inner circles.
Like the pretty rings.
Of pretty rings inside this dome that has been pushed up.
Okay.
And yes.
And how do they explain this happening in an evolutionary timescale? What would be the general explanation?
General explanation is simply that it's millions of years old. Okay. It was pushed up as a dome, a landscape dome, a landform dome. And then over millions of years, there's been erosion occurring at a slow rate. And the weathered rocks have suffered more, the softer rocks have suffered more from weathering than the harder rocks. So that's why you get some little ridges sticking up and others are not. They're more like hollows, and there might be some sand dunes blowing in that, confusing the whole situation.
All right.
So the standard story is one of a long period of time is the classic model.
All right. And then would you agree with this?
No, and I think the evidence against that is quite strong.
Okay. Tell me, what is it?
Well, first of all, if you have erosion from whether it's wind or water or whatever, concentric circles aren't retained. Erosion over that area is never uniform. You're not going to get 50 kilometres in one direction and 50 kilometres in another direction in a huge area undergoing the same erosional processes. It doesn't work like that because there's a lot of variability in erosional processes, even in our own landscape today. So you would not see that beautiful circular patterns. Number two, the amount of the dome that would have had to be removed is massive. Now, the question you've got to ask about that is, well, where is it? Where is the sediment that was taken off of all that? It's not nearby. It's not anywhere near. It's not even on the continent.
So there's not even like little drops or deposits or...
Well, nothing of significance, put it this way. Nothing that can be traced back to explaining that massive volume. So you've got a huge volume of sediment that's just gone, or rock that's gone, turned into sediment, but it's been washed an incredibly long way off.
Without dropping any?
Yeah, basically, yeah. You're not looking at any deposits of this sediment. Can't be found. And so we have a massive dome, which is, again, you imagine it 50 kilometres in one direction.
That doesn't make any sense.
High as, no, that's right. And so you've got these challenges here. Then you've also got the problem that the secular world says that North Africa only became arid 5,000 years ago. And during that entire period before that, it was an incredibly, let's say, lush river channels, lakes being formed, deltas, lovely vegetation, forests, everything.
I've heard of that theory, yeah.
Yeah. So if you're arguing that over all those years, hundreds of thousands of years, I'm sorry, but those rivers and whatever were there would have carved that up. You would never see a feature like that in a river environment. And so I disagree with that. If the vegetation is not the same and the processes are not the same, and we can't find the remnants of the dome,
then
I can't accept a long age model at all.
And so then what's your alternative explanation?
Simply that with the Noah's flood, in the recessive stage when the waters are rushing off, yes, we have the dome coming up, being pushed up. As one of the Psalms says, the Lord said, I will raise the land with one hand and lower the seafloor with another. As he raises the land, there are still flood waters incredibly deep. They're now carving, smashing still parts of the new landscape that are being created, eroding them away. So the top of that dome was completely shaved off by massive waters. That sediment was washed.
That explains where the sediment went.
It's gone way. Disappeared a long way. And so you've now got these beautiful concentric circles that cannot be explained by normal erosive processes. It was one catastrophic event that gave it a sort of a pattern.
And left it completely undisturbed at this point
Yeah,
in time.
because it just stripped off the top but didn't touch the bottom.
And so for our fourth destination on this journey that we're travelling, where are we going?
Well, as I said, we're going to a different continent each time. This time I thought we'd go to the boundary between, basically to Turkey, the boundary between Europe and Asia, and have a look at what's known as the Fairy Chimneys.
Oh, that
in
sounds so whimsical.
Turkey.
I'm keen. I'd love to see the pictures of this, guys.
It's an interesting term. It's actually because it actually does look like a chimney, these features, and they're all over the landscape there in central Turkey. And they're an unusual feature. That some of them look like pillars, some of them look like mushrooms. They're incredibly tall, and some of the leaning and all sorts of things. But no, it's a beautiful landscape. Very beautiful landscape.
Sounds unreal almost.
It is almost unreal. In fact, when you first look at it, you almost imagine yourself in a, let's say, an episode of Stargate or Star Wars, because it's an environment you just do not expect to see, of all of these pillars, so big, in fact, that people live inside these pillars of sediment that just come up out of the plains and out of the hills. And there are thousands of them. Thousands.
That's amazing. It's so unique. And so how do scientists explain this very weird and wonderful landscape?
Well, I'll agree with them that it's volcanic in origin. So a lot of volcanic activity has occurred there. And so you've got what they call as tufaceous material, tuff. It's simply the ejected ash, volcanic ash, that's come out and laid over the whole area. And it's a softer material. It can be more easily eroded. But at the time, there was also then other flows of basalt, much more resistant material that flowed across the top of that volcanic ash and created a layer there that's more resistant. It wasn't quite flowing thick. It was flowing, irregular. And so some parts fell apart and so on. But what you've now got is a basalt on top of a volcanic ash.
Okay, and so these little pillars we're seeing, I'm assuming, with a bit of erosion, the basalt part became the cap, and then the little pillar part was the soft rock.
Correct. The basalt is your capping. Now, it's highly fractured, that basalt, so weathering can occur between pieces of basalt. And what you see then is the separation of these pillars, if you want to call them that. And as I said, they're fairy chimneys because they often look like it's a hat on top of that.
This is so cool. Guys, I did not know this environment existed.
Yeah, and so what happens then is the lower layer, while still there as rock, is easily chiseled out and tools can be used. You can build houses inside that, and people have done that, and you've almost got your roof on top, which is the basalt.
That would be the coolest.
And it's not even ground level. You can move 1 or 2, 3, 4 stories tall.
Well, how big? How many stories?
Oh, some of them got 5, 6 stories.
Oh,
they're huge.
That's like a skyscraper.
These are big pillars.
Whoa. Okay,
Yes.
So this is not just like a little fairy thing.
No,
This is like skyscraper
these
size.
These are big pillars.
Okay, so Where's the problem then if you agree with the geological formation of these rocks?
Again, it comes back to time. And I'm always challenged by time. In this case, they'll argue that that occurred millions of years ago.
Okay.
And I'm going to disagree with that.
Why?
Because it is volcanic, and I don't have a problem with volcanic, but I would argue that most of the volcanic activity occurred at the time of Noah's flood, the time of the global flood. Mm-hmm. And so we saw a lot of that activity then. And that would have been 4,500 years ago at that time. That was then followed by an ice age, which wouldn't have impacted dramatically on that region, although surrounding it in the higher levels of the mountains in Turkey would have been glaciers going at that time. And we're aware of that even from scripture and other research and writings from that period as well. It's not an ice age, it's simply a growing of the amount of ice on mountaintops and so on. Mm-hmm. So when that melted, you would have seen a massive flow of water even there going on. Now, the volcanic ash is not that strong. If we can build houses in it and build staircases and everything else out of it, we know that the processes of erosion are going to be rapid. So if you've now got normal rainfall, but then supplemented them with runoff from the ice age, surrounding the area, I certainly, let me be blunt, I cannot explain, I don't think any scientist can explain how volcanic ash can stand unweathered for millions of years. They would collapse in no time whatsoever.
So this shouldn't be here.
So this carving into these pillars would have been extremely rapid, and they are no longer being carved because we don't have the incredible rainfall, the incredible runoff, the ice age melting, and so on. Mm-hmm. So again, it comes back to a time matter, because those sort of rocks don't withstand erosion for millions of years.
Hope you're enjoying the interview so far. We'll jump back in shortly, but real quick. Imagine bringing this life-changing message to your church or community. This is exactly what we do. We present at close to 1,000 events each year. So many people struggle with how science and the Bible fit together, and it becomes a genuine stumbling block for their faith. But our speakers present satisfying answers that really make sense. We've received hundreds, possibly thousands of testimonies from people who have had their lives changed through our speaking ministry. If you'd like that for your congregation or community, then use the link in the description and contact us today.
So speaking of people and time, what was interesting that you were mentioning to me before about these people who lived in these pillars?
Well, we know they've lived there for some time because archaeological evidence points to 2,500 to 3,000 years. And so no problem with that. But I think what's really fascinating is that in the 2nd and 3rd century, a lot of people actually lived there, and they were Christians. Because at that time, the Roman Empire was persecuting Christians. And so they were fleeing to these particular pillars and building houses in them. Because there were so many, they could actually hide within them.
That's amazing.
And escape from the persecution. In fact, in recent archaeological work of really unravelling a lot of the older ones, you're going to find this hard to believe, but they have uncovered over 1,000 churches are actually embedded in these pillars in this area, over 1,000. So it was a refugee place, if you like, for Christians in the 2nd and 3rd century, and the evidence is overwhelming. So interesting little feature if anybody gets a chance to go there to have a look at that.
There you go. The Christians used to live in random fairy pillars of rocks. That's amazing. All right.
Yes.
And so for our 5th destination, where are we going this time?
Okay, we're going to some place that nobody who is listening here today, I'm sure, has ever been.
Okay.
Because we're not staying above water, we're going below water.
Okay, so I should bring a wetsuit.
You could get away with a wetsuit. I'm not going that deep.
Okay.
So
where are we going?
We're actually going to a place called the Sunda Shelf, which is it's the continental shelf between Vietnam and Indonesia. And it's the continental shelf that continental shelves, if anybody's uncertain, are those shallow areas that surround most continents. Sometimes it goes out a long way, sometimes it doesn't. It's usually depths of, say, 80 metres or 100 metres before we plunge into the depths of the oceans. So you've got your coastline, you've got shallow waters going out, could be going out hundreds of metres, hundreds of kilometres or thousands of kilometres, and then it'll plummet into the deep ocean.
Okay.
So these are continental shelves, and there's an incredible one in the Sunda Shelf there in Southeast Asia.
All right. These are sounding really interesting. And actually, earlier when I was looking at this, I actually looked at Google Maps, which is a pretty layman's way to have a look for a continental shelf. But there was all these like shallow areas around all of the. Is that what you're talking about?
Exactly.
Yep. Okay.
Yes.
So we're looking
It's
at.
the light blue on a Google map.
Okay. Nice. Okay. So if you want to look it up, you can have a look. What do we know about what's down there? What's interesting about this?
I think what's fascinating is we found everything down there that we would find normally on land.
Like.
There are abandoned river channels, massive river channels, bigger than we see even on land. There are deltas, there are floodplains, there are lakes.
You mean there's a
freshwater-
whole entire landscape?
There's a whole entire landscape down
That's
there.
not sea landscape. This is
No,
land
this is a
landscape.
land landscape, yes.
That's interesting.
So the continental shelf was at one stage land.
Okay. And so if we're looking at this from the eyes of a secular scientist, what are they saying about this?
Oh, they agree.
Oh, okay.
They agree entirely because they argue, as I will agree, that it occurred during an ice age when the sea level dropped, let's say 80, 100 metres, whatever it was, according to the current estimates. Mm-hmm. What you then have is the exposure of all this extra land around every continent. Mm-hmm. And in some cases, like Southeast Asia, Indonesia, New Guinea, you're starting to link them up as one piece of land rather than multiple pieces, rather than islands.
Ah.
And they were not barren. They were not, deserts. They were actually wonderful, productive coastlands.
So you're telling me these were land bridges?
They were land bridges, and so I don't disagree at all with the secular scientists on this one. What's fascinating is that these features of the original landscape are still there.
Okay, so why would they still be there?
That's the question I'm asking. Why are they still there? Because if you follow the secular way of thinking in the Ice Ages, they argue that the sea level rose slowly.
How slow are we talking?
We could be talking a metre in 1,000 years even. Now, it could be better than that, but the point is it's a slow rate of rising sea level.
Okay,
So
and why would this destroy the idea that the landscape shouldn't be there?
Because if the sea level is rising slowly, anything that gets in its way from wave action daily, tidal action daily, storms, will remove the evidence of the previous landscape and turn it into essentially sand dunes and all the rest as it pushes it up.
Wait, we had this happen recently with the cyclone that hit Queensland.
Yes.
Our whole shoreline was
Is completely
destroyed.
turned over. So if the sea level had risen slowly, what you would see is a total destruction of all those features on the ocean floor.
So no rivers, nothing. It'd just be
They would all be churned up.
Okay.
Absolutely. But we see these features, and I've used that as a good one, Sunda Strait, but you'll see these anywhere, really. You'll see them in Europe, linking England, Denmark to Sweden, and all the rest of it. These features are everywhere, and they still retain the original landscape features. So if you do go down there in your wetsuit, you will see incredible landforms down there that should not be there
Okay.
because they should have been. Now, for example, the Sunda Delta goes out like a delta and then drops off dramatically at the end. Well, as the waves and as the water level rose and the waves, they would smash that delta. Delta is just unconsolidated sediments, weak as, easily turned over and turned into sand dune stuff. We've seen it in other locations around the world. Yet there it sits perfectly in its original structure. In other words, that sea level did not rise slowly. It rose incredibly rapidly, which is what we argue about the Ice Age following, and have argued this for many years. Sea level rose rapidly. So the fact that we find these features is not at all surprising.
Okay. And so this is activity happening in the Ice Age after the flood, not a pre-flood landscape.
No,
after
there
the
is
flood.
no pre-flood landscape.
Yep.
What we're seeing here, and this is where some people do become a little bit confused, as we start to find, let's say, artefacts or settlements offshore on the continental shelves, we ponder, is that pre-flood settlements? No, it's not.
The flood would have just turned everything over
Turned
completely.
everything over. They don't belong to that. They belong to a post-flood and a migration of peoples.
So wait, how long did this Ice Age actually last?
Well, our best estimates place it at about 700 years.
Okay, so if we're looking at a biblical timeline, then the Tower of Babel would have been during an Ice Age?
Yes, because the Ice Age was initiated basically at the end of the flood itself, at the global flood.
Okay, and then when Abraham is called out, that would have happened at the end of an Ice Age as well.
Yeah, particularly the Tower of Babel and so on happened, and even Job refers to ice in areas where it's not found anymore.
Job refers to it?
Yes.
Wow.
And so what we see then is we're in an Ice Age, the Tower of Babel occurs, and then people begin to move.
Yeah.
Well, what I'm arguing is we now have wonderful proof or wonderful evidence of people being able to migrate to any continent.
Yeah.
Because the sea level was lower.
It's literally the way is fully clear for them to go.
Fully cleared not only to migrate but also to settle on continental shelves.
Oh, okay.
Because they're productive.
As you do. All right. And then you just mentioned though earlier that the Ice Age only covered the ice caps. Can you explain why was Job seeing Ice Age?
Well, when you had the Ice Age, what you'd see is it would cover large areas of northern Europe,
yes,
coming down into England as well. Siberia and so on, Canada and parts of the USA were covered. Really didn't affect the southern hemisphere. So people mistake the Ice Age as being global.
Okay.
It was not. It was sufficient Ice Age to lower the sea levels, to 70, 80 metres, 100 metres in depth. What you would have seen, though, in the rest of the world, particularly in those areas near an ice, near the actual coverage of Ice Age, you're going to find high mountainous areas, say in Switzerland and Turkey and other places like that, are going to have a growth of ice, growth of snow, glaciers developing in those areas as well, that today are not there.
Okay, so that's why Job was able to see ice.
That's an idea I have, yes.
Okay.
But I wasn't there with Job, unfortunately, but he does refer to ice, and it's the one instance in the Bible where it is referred to.
So you were talking earlier about settlements on these continental shelves. What do we have in terms of evidence for this?
Oh, that's surprising that in recent years, with better technology and the ability to explore the ocean floor, or rather the continental shelf in more detail, we have actually found artefacts, human artefacts, previous settlements and all sorts of things. We found them between off the shore of Denmark, for example. There's been a settlement found there. We will be publishing things shortly in the Creation Ministries literature of other settlements or artefacts found off the northern coast of Australia, Northern Territory, Western Australia, and so on. Now, they're quite some distance out, but the point is they're concentrations of settlement. So people did migrate. And I think as we do more research on the ocean floor, which we've turned a blind eye to in terms of humans, I think we're going to find a lot more settlements there, because if it's going to preserve the rivers, the deltas, the lakes, I think it's going to, they've not been covered in sediment. Therefore, we're also going to find a lot of human artefacts out there as well, highlighting the migration.
That's really cool. So you're telling me that all of these peoples, who are the island peoples, were all from the same people group, but they all migrated through to Oceania, and there used to be a large landmass, but it got covered, and now we just see the tops of the mountains for them.
Yes.
That's amazing. All right.
But I think also that explains to a lot of people why, when you look at species of plants and animals, people ask, how did a kangaroo get to Australia? Well, it didn't have to swim.
It just hopped.
It could have hopped most of the way, and the waters that would have been there that still were remaining even in an ice age would have been so shallow. And I've seen kangaroos swim, by the way, so they can do it.
So we could have got to Fraser in Australia. There wouldn't have been a channel.
No, Fraser Island that you're talking about was not an island.
Okay, so it was part of the mainland.
It was part of the mainland.
Okay, so we've covered these 5 landmarks today, and you're telling me that you're in agreement with some of these areas and not in agreement with others. Can you explain to me, what have we learned today?
Well, what I am in agreement with is the geology.
Yep.
I can't see any problem there. It's factual. We can visualise it. I don't have any problem basically with the morphology, the shape, the form, because again, we can measure it, we can visualise it, and so on. In terms of the processes that create these landscapes, I have some challenges at times. In most cases, I'd agree, but not necessarily with the rate of the processes. Some of these features, like the towers in Turkey, shouldn't still be around after millions of years. And so that is a partial agreement. But I think the biggest challenge I face when we look at all of these 5 features is essentially time, in that the argument that it took millions of years can be dismissed in almost every case. The pillars in Turkey should have eroded and collapsed a long time ago. If the eye of the Sahara had been eroded by over millions of years, there would be masses of sediment found around it or nearby within the drainage systems, and it's not there. Equally, if the, let's say, the continental shelf features had been buried a long time ago by a slow process, they wouldn't be visible anymore. So in other words, I'm suggesting that things have moved a lot faster in time. How do I then explain that? And this was a significant impact on me in becoming a Christian, is that if things happen fast, it turns out they actually, relative to the secular view, it's actually perfect matching on a biblical view. In other words, 4,500 years ago, we had Noah's flood. A global flood occurred, smashed the earth to pieces. What we had then was the land was raised, and a lot of these features that I talked about were carved by the flowing water off the landscape as the continents were raised, carving them up. Some of them were also affected then by the Ice Age that occurred immediately after the flood. And I know we have some other YouTube on that as well. So if people want to have a look at that. So that's all very rapid in that time. And then what we have seen since is minimal change over time since that catastrophic flood, catastrophic ice age, dropping of the sea level following with the flood. We are left with a historic landscape, not a currently being formed landscape.
Interesting. And one of those examples that you gave was that you think that these big riverbeds, these floodplains, were actually massive rivers as they were running off the land.
Yes.
And now we just have a mini river that's just the drainage point, just because it happened to be the lowest point.
It happens to take an opportunistic pathway.
Yep.
It didn't create the valley. Mm-hmm. It just simply uses the valley. Mm-hmm. And, even the secular scientists are confused over this because they agree that river did not cut that valley. And so I come back to a biblical point of view here, is that things from a geomorphic point of view, from a geologic point of view, and from many other points of view, point to a short timescale, incredible catastrophic event, followed by subsequent events of erosion, ice age, and so on, created a landscape that today sits as a historic landscape for us, not as a currently developing landscape on a global scale.
That's so interesting. It's like the Psalms have said that God has left his handiwork very clear and that we're without excuse to be able to believe his word.
Absolutely. And when I mention this in churches, when I say to people, when you go out there next time and you see what a beautiful landscape this is, realise it's actually the leftover of a catastrophic flood. I can tell you it doesn't go down comfortably well with a lot of people because they used to look at it as though it's a wonderful feature of creation. No, it's not. It's an actual feature of the destruction. And,
it's a reminder.
It's a reminder. It's an absolute reminder. Yeah, I like that.
All right. Thank you so much, Ron. It's been a pleasure to have you on here. I've learned some really interesting things. I didn't know that Job was in the Ice Age. That's really cool.
Certainly lived during that period. Yes.
Yep. Okay.
Yes. I'm not sure he went skiing, but anyhow.
All right. Well, yes. I haven't seen, though. It's so cool to be able to see a refreshing, different viewpoint on some of these huge landmarks that we are told formed over billions of years. But by someone who has studied them, we then get to see that actually maybe it's not as settled as people think it is, the interpretation of these physical characteristics.
Agree.
All right, and so we have a free streaming resource here for people to have a look at. Do you want to tell me about this?
Oh, this one is excellent. It's actually 15 of our top speakers, scientists, highly qualified with PhDs from a range of different areas of science. And some of these are very top scientists. And I think when you map all of these features, not like we just talked about today, where we're looking at landforms, but when you start mapping a whole range of features that you see, and we'll see on this particular product, whether it's biological, whether it's astrophysical, whether it's geological, whether it's fossils and so on, what that really builds a picture even stronger than what you and I talked about today.
So you're saying
a complete picture.
Evidence from many different fields very interestingly happens to coincide. and maybe that's not a coincidence anymore.
No, I don't think it's a coincidence. I think it's... No, I agree with you. It's a great resource, by the way.
That's awesome. All right. If you guys want to look at this resource, you can click the link in the description below. Thank you so much, Ron. Really appreciate it.
No, thank you.